What is the specific heat of the solid, liquid, and gaseous phase? So here's our solid phase, right? Here's our liquid phase. Whoops, hard to circle things. This is our gas, so solid, liquid, gas. And what we're going to do is use MCAT, right? So Q is MC delta T. So therefore, C is just Q divided by M delta T. And we know that the mass is 0.026 kilograms for all of these, okay? So all we need is the heat that flowed in and the change in temperature. So for the solid, I'm going to say that 50 joules flowed in. That's because it's halfway, right? So Q is 50 joules. And then our change in temperature is from 0 to 40, right? So delta T is just plus 40. So for the solid, C is equal to 50 joules. So it's Q over M delta T, right? M is 0.026, and our delta T is 40. So what is that? 50 divided by 0.026 divided by 40. That's 48.1, 48.076. And that's joules per kilogram degrees Celsius. All right, now let's look at the liquid. So for the liquid here, the heat that flows in, it starts here, right? And it ends here. So I'm going to say that the heat that flows in, Q is going to be 500 minus 250. That is 250, right? The change in temperature is from 40 to 80, so that's also 40, right? Okay. So notice if the line is less steep, that means it's harder to heat it up, right? So it's got a bigger heat capacity as a liquid. Okay, so liquid, C is equal to the 250 that flowed in, 0.026, and again, the change in temperature here again is just 40. So 250 divided by 0.026 divided by 40 again is 240.4. So 240 decimal point joules kilogram degrees Celsius. All right, now let's look at the gas. All right, let's see the gas. The gas is steep again. I don't know if it's as steep as the solid. I think it's a bit less steep. Okay, so our Q is, it starts at 800 and ends at 900. So Q is 900 minus 800, or just 100, right? 100 joules flows in. And then our change in temperature is 20, 40, 50. Is that right? Change in temperatures from 80 to 130. That would be 50 degrees, right? 50 degrees Celsius is this delta T, right? Okay. So specific heat is going to be the 100 joules that flows in divided by 0.026 divided by 50. So 100 divided by 0.026 divided by 50. And that's 76.9. So 76.92. And that's joules per kilogram degrees Celsius. All right.